И снова здравствуйте.
Good afternoon, everyone. Hi, everyone. Hi, Vladimir. Well, finally, I met you in person. The last time we met in person was in April. So we'll be talking about the JDK sorting. Please raise your hand if you were not asked the question, what happened if you use sort command. Well, I was asked this question at any job interview, regardless of the position. And today we have a speaker who directly took part in and had a huge impact on how it works. Vladimir, the floor is yours. Hi, everyone. Indeed, my name is Vladimir Yaroslavsky, and I'll be talking about the JDK sorting. Its evolution, its development, and its future development. There will be a Q&A after the report, and the author of the best question will win a T-shirt and a prize personally from me. So get ready for the Q&A. Though the title of my presentation is Evolution of JDK Sorting, so Java specifics are not going to be part of this presentation. So by the way, please raise your hand if you use Java programming language. Please raise your hand if you are not a programmer at all. Right, there is just one person. I still hope that you'll be interested in learning about algorithms. If you take a look at various programming languages, that you'll see that quicksort is oftentimes used, team sort in Python. Intrasort is not an algorithm, it's just a hybrid of quicksort and heap sort. If you are not familiar with JDK, JDK is a set for a developer which comprises not just a compiler, but also libraries of various system classes. And that also include the sorting tool, which I'll be talking about. If you are a Java programming language, so the question is, if you put race.sort, what sorting will be invoked? Any ideas? Some people say it's quicksort. Well, I'm not going to ask you difficult questions. It's going to be team sort and dual pivot quicksort. And being the author of this sorting algorithm, I'll brief you on its evolution. So, why do we need two algorithms for sorting? One for objects and one is for simple things. So, I'm going to give you the answer later on. Until version 6, and that it's included, we used the classical merge sort sorting, and for and we used the quicksort single pivots quicksort that was developed by John Bentley and Douglas McElroy. By the way, did you program on version 6? Do you still use it in production? Right. What's different in JDK version 7? Both algorithms have changed. They use team sort for objects, and they use dual pivot quicksort for data types. I developed it back in 2009. It's just a coincidence that both algorithms were updated in 2009. So this is the agenda. I'll brief you on team sort, then we will deep dive into the dual pivot quicksort. Then I will be talking about sorting testing. We'll touch upon some other issues, and there will be a Q&A at the very end. And like I said, get ready with your questions because the winner will get 2 prizes. Right. As for the team sort history, back in 1993, Peter McElroy suggested an idea on accelerating the merge sort for structured data. And Tim Peters used this idea. He implemented it in Python, and he called it team sort after his own self. John Block converted it into JDK 7. Let's try and recall what merge sort is all about. The algorithm is quite simple. You split dataset into 2 or 4 parts. You sort it recursively, and then you merge both sorted parts into into a single dataset. Team sort uses structured sub sequences. At each step, we look for growing or shrinking sub sequences, and we use insert sorting. And then at every stage, we merge the structured subsequences into a data set. How quick is team sort? If you use random data, then it features the same speed as merge sort, but it's way faster if you are talking about structured or almost structured data, periodical data. The comparison was run on a test dataset proposed by John Bentley. So let me briefly go over it. We have different types of data: random, structured, repeating, and so on and so forth. In every dataset, we use several modifications, and we use several parameters to build a dataset. We compare the algorithms in multiple combinations of the data types in different platforms. Now let's move on to the dual pivot quicksort. It was proposed by Charles Hoare over 60 years ago, and the main idea is as follows. You choose an element that we call a pivot, and all smaller pivots are sorted to the left, larger are sorted to the right, and that gives us two sorted categories. We recursively sort them out, and we get a sorted data set. But what if we have two pivots instead of one? The idea is basically the same. The elements are sorted in the following way. Elements lower than pivot 1 go to the left, larger go to the right, and the same holds true for pivot 2. The idea to use several pivots is not a new one, and it was stated a long time ago. Back in the late 1970s, Professor Robert Sedgwick, in his PhD thesis, studied quicksort, in particular this particular dual pivot algorithm, and he believed that this variant is 2 times worse than the exchange required by other algorithms, and his conclusion was that this algorithm was not promising, and he never considered it again. However, I didn't know that, so I decided to try it myself. In 2008, I came up with, in August 2008, I came up with an idea of using two pivots. I tested them on lists. Then in late 2008, I finally implemented this idea for data sets. And my first draft was only 5% faster than JDK 6. And of course, this is not enough to become part of JDK. So I kept on improving it, and in spring 2009, I became an email pal with John Block, and he told me that I needed to improve it, that the sorting should be faster in all platforms. We optimized it in summer 2009. And later on, he wrote John Bentley and said that there was an option, the results of which were quite sellable. So he gave me a couple of valuable pieces of advice how to improve it. And in September 2009, we named it Dual Pivot Quicksort, and Josh Block helped me integrate it with JDK. Since then, I've repeatedly improved the sorting algorithm, optimized it, and it has still been improved.
Если сравнивать с версией
If you compare it with JDK 6, then dual pivot quicksort algorithm, at least the latest version, is faster when it processes all types of data. To ensure such performance, we had to solve multiple technical problems like how to choose a pivot, how to sort small data sets, and that's exactly what I'm going to touch upon right now. It's really important to be able to sort small data sets very quickly. Why is that? If you get a large data set, you will split it into smaller data sets, and then each small data set will be sorted with the help of injections.
уделить было большое внимание.
So much attention had to be paid to sorting small data sets.
Элементов быстрее.
Several dozen sets are faster to be sorted by insertions rather than quick sorts, so the algorithm is quite simple. You get the next element in the follow-up stage and put it into the sorted category, and step by step the data set becomes sorted. This slide shows the classical implementation of the insertion data sets, and there is a test whether index J is shifted to the left. This test is calculated at all times.
И хотелось бы избавиться от такой дорогой проверки. Если посмотреть на
if you take a look at it in the quicksort context, you'll see that the yellow part is sorted and all of the elements are equal or smaller than the first pivot. Therefore, when we sort this part, we will not exceed the left-hand cutoff point because we have P1 as our pivot, and it acts as a sentinel. Therefore, you can just remove this part, and if you delete a condition from an internal cycle, it will boost performance. One is good, but two is better, and we as programmers should be able to use it in several places. So let's try to insert a pair of elements. First a larger element and then a smaller element. But we do not go from the right-hand most part, but rather the place of the larger element. That reduces the number of exchanges and the number of comparisons, and that speeds up the sorting process. As for the pivots, quicksort is probably the only algorithm which is not that precise. It just says you need to select a pivot, but no one knows how. The option that you come up with is going to be used by the quicksort. That's why there are so many quicksorts around. The author suggests random selection of pivots. You can use fixed pivots, median or medial. For instance, if you have 9 elements, out of every 3 you pick the average and do it again. We experimented with it, and it turned out that the best pivots are if you take 5 elements that are the most remote from the center, you sort them, and the best one will act as a pivot. So what distance should we specify? The rule of thumb is the length of the data set multiplied by a number. However, it's too expensive, especially given the fact that we need a whole number. Therefore, we will replace it with a cheap approximation with the shift to the right. As was mentioned, one pivot quicksort is fast, two pivot dual pivot quicksort is faster. I tried 3 pivots. It was slower than the dual pivot quicksort. There is a quicksort with no pivots. It doesn't work that well. So the truth is somewhere in between. So it's not 1 or 2, but the optimal number of pivots is 1.6. Do you know what that number stands for?
Ну, это золотое сечение.
That's the golden section that you see everywhere in nature. Pineapple, fruit, egg. It is used in painting, photos, and so on and so forth. So all you need to do is just see it and use it. So the question is, how do we sort between 5 elements? You can use the well-known insertion sorting algorithms, and you'll get 10 comparisons. If you have fewer elements, then you can use sorting meshes, and that's the way we sort 5 elements and only get 9 comparisons. That's not such a big difference, but then it's still good. Splitting the data set. On the left-hand side, we get elements lower than the first pivot. On the right-hand side, larger than the second pivot. But if there is no match, then the division is simpler. It's similar to the national flag problem. The middle part contains elements that are equal to the pivot. In other words, all the elements are equal, and that means that this part has already been sorted, and we can remove it from further sorting. Let me remind you what the national flag problem is all about. We have stones of 3 colors. We can identify the color. We can change their locations, and we need to sort them. It's a simple task. If you have 2 pivots, then the sorting is fast, but if you launch a single pivot quick sort, it turns out to be faster if you have repeating data like 0.0123, 4, 0123, and so on. And this data should be sorted by the single pivot quick sort algorithm. How do we do that? Let's use a very cheap approximation. Let's switch over to the dual pivot quicksort algorithm, not only when there is a match, but when there is a mismatch of all 5 elements that we use to identify the pivots. And the repeating data will increase the probability of using the second algorithm. As for the substantial numbers,
наверное, математики. Если у нас 2 элемента равны, означает...
If the 2 elements are equal, does that mean that they are represented identically? I asked the mathematicians, and they said, of course, it's a definite yes. But what if the elements are not equal? Does that mean that they are represented differently? It should be a yes, and the mathematicians also say yes, but Java is not about math, so the answer is no in the case of Java. How come? In the Java world of real numbers, there are 2 anomalies. The first one is -0, which equals 0, otherwise mathematicians would have killed us. And there is a different bit presentation. And there is another weird thing, such as not a number, which does not equal anything. So the real numbers have to be sorted with the help of additional steps. And JavaDoc features the following sequence. First, negative numbers, minus zeros, zeros, positive numbers, and not numbers.
У нас для
And for real numbers sorting, we're going to use the following algorithm. First, we scan the data set, and all the known numbers go to the very end. Then we calculate the number of minus zeros. We replace them with zeros. Then we sort everything but the non-numbers. And then all the zeros will be replaced with minus zeros if you know what the bit presentation is in the Java for the minus 0. If your algorithm
написать параллельную имплементацию.
can be run in parallel, then it makes sense to do so. And Java util concurrent is a great packet which features multiple useful things, various classes. And if you want to do the parallel defragmentation algorithm, all you need to do is take one method, specify the business logic, and Java will do the rest. We're not going to do that because it's already there. Starting from version 8, there is a parallel sort option that was based on the merge sort algorithm, both for primitive data and objects. We know that quicksort is faster than the merge sort, so the parallel versions, the parallel sort, should also be based on parallel sort. Well, on the face of it, this is so, but not really. If you take a server with multiple processes, the parallel merge sort turns out to be way faster than parallel quicksort. Therefore, from version 14, we started using the hybrid. First, depending on the number of CPUs and the size of the dataset, we launch a merge sort, and then we switch over to the dual pivot quicksort.
Очень много мы уже
I've talked at length about sorting algorithms, which is better, which is worse. Let's imagine you get the following question. What's the best sorting algorithm? You attended this talk, so you should know the answer. Is it the quicksort with the N algorithm, or is there a better algorithm? Let's say we have a data set, and we know that it only contains zeros, ones, and twos. How would you sort a data set like that?
Ну, правильно, да, у меня ответ-то написан.
Exactly, that's the answer. I'm not gonna, like I said, I'm not gonna ask you difficult questions. All you need to do is count the number of zeros, ones, and twos, and then you just write them down. And it's linear time sorting. Awesome. All you need to do is count it and write it down. It would be great if we could use the same algorithm for sorting numbers. And actually, there is an algorithm like that. That's the radix sort. First,
Третьему, четвертому и так далее. И уже получаем отсортированный массив. И опять же за линейное время.
we use the order of the numbers and the number of digits.
Какой у нас размер массива?
We have to take into account the context, the data set size, additional memory that might be required, the complexity to say what algorithms is better. Therefore, based on the context, this or that sorting algorithm would make sense. This slide shows the best sorting algorithms that I already mentioned earlier on. And down below in the center, you might see heap sort. So how come it's there? I'm going to give you the answer in a second. If you compare team sort and quick sort, you'll see that the team sort is ideal for sorting objects. It's a stable algorithm. It doesn't change the order of equal elements, while quick sort is not that stable. Quick sort does sorting in memory. Team sort requires additional memory, while quick sort has the following drawback. In a specific data set, it might result in a square complexity problem. So we use heap sort. We switch over to heap sort if we go into recurse mode. So the JDK implementation guarantees that it will not be worse than the linear complexity or the logarithmic complexity. I already said that team sort is more stable, while quick sort is not. That's why we have two implementations. According to Java doc, object sorting has to be stable, regardless of the implementation or the algorithm that is used. Quicksort is not stable, therefore we cannot use the very same algorithm.
Вас просят на собеседование.
If during a job interview you get a question,
Какая же сортировка самая лучшая?
what sorting algorithm is the best? The short answer is as follows. The best implementation is in the Java util dual pivot quicksort that contains a huge set of various sorting algorithms for any situation you might come across in life. Please raise your hand if you don't like writing tests.
Молодцы, честные ребята.
Good job. Thank you for being frank. Please raise your hand if you don't write these tests. Well, please do. If you don't like it, ask your colleagues to do that. They will be happy to help you. I'll tell you why that is important in a second. Team sort is not ideal, just like the world we live in, and it contained an error. It contained an algorithmic error. In 2015, the key verification system found an error, detected an error in team sort. First, they patched it,
Ошибка.
but the algorithmic error still remained there. However, they couldn't replicate the error. So from the mathematical point of view, it's an algorithm with an error, but from the Java viewpoint, there was no error because JVM did not support the huge data set that it needed. And the algorithmically, it was corrected later on. There is an article posted on Hubber. You can read it at your leisure. Quicksort is not better than team sort, and versions 8 to 13, the parallel sorting of real numbers contained an error. It failed to properly sort the anomalies. In version 14, it was debugged by me when I had to rewrite everything. And I was not the one who made this error in the first place. So I hope you realize, and I hope I convince you, that tests are a must. That's why you need to write them. Let's imagine that you have an algorithm, you implemented the sorting algorithm. Let's verify that it's correct. We write a test that the follow-up element is not inferior to the previous one. And the sorting algorithm is so tricky that it just refreshes the data set, and it will pass the test, which is not good. So we want more tests to detect such errors. So what we can do is we can add a second algorithm with no errors, for instance, insertion sorting, and it only contains 7 lines. We know that there are no errors. We do sorting with one algorithm, with another algorithm, and we compare the results. The idea is good, but only for small data sets, because if the data set is huge, then the insert sorting will take too much time. We can go in a different way. We can take a structured data set, because we know what should be in the in terms of the results, and then we compare it with the benchmark. It's a good idea. It could be implemented, and it is. But sometimes you want to test your algorithm with non-sorted data sets. What do we do in this case? Well, the idea is as follows. We take the unsorted data set and we calculate its control sum. For instance, the sum of all elements, then we sort it, and then we calculate the control sums again. And if they do not match, that means that our algorithm is wrong. So
Для сортировки существует очень много тестов, включая...
There are many tests such as benchmarks, correctness tests. They were proposed by John Bentley and so on and so forth. In other words, there are more tests than code lines.
Добавлю, что Dual Pivot Quicksort
Dual pivot quicksort
более 15 лет
has been in operation for more than 15 years, and it's available not only for Java but also for Android. The Android version is slightly outdated. Going back to sorting, you know that you can sort objects or you can sort numbers. I selected 60 arbitrary numbers and I converted them into different data and structures, and you can see what happens. Lists are sorted faster than arrays because you need to convert from a list to an array, and then you need to convert back into a list. The strings are converted slower than integers, numbers and objects.
Поэтому это тоже нужно учитывать. А примитивы
And primitives are sorted several times faster than the objects. Short are sorted even faster because a special type of sorting applies. So if your app sorts data often, you take a look at the type of the data, and only by selecting the right type you can accelerate your app. If you select an ID type, it should be a string, or can you do with a number? Should it be an integer with a capital letter? Or can you do with just a primitive, long it? Or maybe it's enough just to stick to the short range. After JDK 7 was released, after a while, the internet started acquiring papers why the new quicksort is faster, because Robert Sachvik said that no, it shouldn't happen. Sebastian Wild here, first in his thesis, researched this matter.
не достиг,
Didn't reach any results, wrote a PhD,
выпустил по мотивам своих исследований 2 книги.
published 2 books,
Ответа нет, так и...
but we still don't know the answer.
Чтобы внести свой вклад в развитие OpenJDK, не обязательно работать в компании.
To contribute to OpenJDK, you don't need to work for Oracle. You go to the website,
Интересную вам группу,
and you go to the group you lay your eyes on, you select the task, code, test one more time, run benchmarks, make sure performance hasn't declined, send it for review, and then be ready to start receiving comments.
некоторых, а возможно и многих итераций, когда ни у кого не останется вопросов,
After all the comments are exhausted, your contribution will be integrated into JDK under a GPL license.
процесс интеграции выглядит очень...
Right now, the integration process looks very familiar to everyone.
У вас есть pull request, и
You have a pool of requests, you've got reviewers, you leave comments, it's all quite conventional. There is a pull request for me for optimization in August last year. It was published in September. Optimizations were proposed by a developer. These optimizations were not algorithmic. They were based on
поддерживающие операции AVX.
CPU supporting AVX 512 transactions. Sorting can be improved not only through algorithms, but also through processor updates and upgrades. So if you have an idea, try it out, try it again, don't be afraid.
С тех пор, как сортировка
Since sorting came on board, it gets better. And again, you can contribute to JDK even today, even in the present times.
Java это
It's all very real. Java is not math, as you have seen, so please be aware of that when you are simulating something or coding. And please always remember about the root of the problem. How can you solve this particular problem in the most efficient way? I'm done. Thank you.